Hello! In this tutorial we are going to learn how to design a trochoidal gear. Recently I saw a video from the YouTube channel Mishing in which he 3D printed this kind of gears. In his video he used a brute force method for generating the tooth geometry. I tried to make a Fortran script to generate a series of points which, when imported in Solidworks, allowed me to sweep one of the rollers and achieve the tooth geometry I needed. But, as you can see, it didn't work because the rollers and the crown gear have interference. So I replicated his brute force method using a mixed approach between Solidworks and Blender. This is great because we have the rigidity of Solidworks tools and the flexibility of Blender to generate the tooth profiles very fast. So let's start with the tutorial. First, we want to define some parameters. We need the pinion diameter, which in my case is going to be 25 millimeters. We need the roller diameter, which I'm going to use 6 millimeter rollers. We need the number of rollers. This is the equivalent to the number of tooth in our pinion gear. I chose 5 rollers. Finally, we need the overall gear reduction we want to achieve. For this tutorial, we are going to create a 4:1 reduction, but you can change any of these parameters as you wish. With this, we can calculate the number of teeth on the crown gear, which is the number of rollers times the reduction we want to achieve. In this case, 5 times 4 equals 20. Also, we can calculate the diameter of the crown wheel, simply by multiplying the diameter of the pinion gear times the reduction. But this method is so flexible that you can experiment with different diameters for the crown wheel without following this relation. Now let's open Solidworks and start by modeling the pinion. First, we are going to create a new part and we are going to design a sketch for the pinion gear, making a circle with 25 millimeters. I'm going to make this constructive by hitting X. I'm going to put one of the rollers at the top. This is 6 millimeters, the diameter of the rollers. I'm going to make a circular sketch pattern, 5 rollers, making sure the center is in the origin. I'm going to make the base for the rollers a bit wider than the rollers itself, so 35 millimeters is good enough. And I'm going to put a hole in the center of 8 millimeters. Now I'm going to extrude this geometry to the other direction, 5 millimeters. This is going to be the base of the rollers. With the same sketch, I'm going to extrude the rollers, making sure to select each one. And I want the teeth in the crown wheel to be 10 millimeters. So I'm going to extrude the rollers a bit longer, so 15 millimeters is going to be good enough. And this is the pinion gear, or the tool we are going to use to cut the tooth on the crown gear. Okay, we are going to save this in a folder called tutorial as pinion gear, and we want to save this as STL also. Now we want to design the crown gear blank. For this we are going to make a sketch on this plane. We are going to make a circle of 100 millimeters. I'm going to put a hole in the center of 8 millimeters, and I want the tooth on the crown wheel to be 10 millimeters wide. Okay, so I'm going to set an offset 5 millimeters bidirectional and base geometry. So this creates a circle 5 millimeters to the inside of the primitive diameter and 5 millimeters to the outside of the primitive diameter. Okay, we are going to extrude. This is going to be the base of the crown gear blank. I'm going to set this to 5 millimeters. And with the same sketch, I'm going to extrude this part like so. And we want to extrude the radius of the pinion gear. So 25 millimeters over 2. And I want a bit of clearance from the base of the gear. So I'm going to add to this 3 millimeters. Just like so. Okay, we are going to select this face, sketch, making sure we are in the positive X direction and positive Y direction. We're going to make a line like so, a constructive line. This is going to be 45 degrees. This is so when we export this piece to Blender, it is easier to locate. The origin will be in here. Now we want to make two lines, one like so, making sure these two are perpendicular. Okay, we're going to make another line like so. Mirror entities, these two. I'm going to make this constructive. And I'm going to set this angle to be 360 over the number of tooth we want in the crown gear. So we want 20 tooth, so 360 divided by 20, it is 18 degrees. We are going to extrude cut through all both and flip side to cut. So we cut everything else instead of this part. Okay, this is the crown blank. Here we are going to have later the tooth geometry we want. We want to save this as blank gear crown, and we also want to save it as STL. Now we can open Blender, hit A to select everything, X to delete, and delete everything. Go to File, Import, STL. We want the two files, the blank gear crown and the pinion gear. Import. Select the pinion gear, shade flat, and the same with the crown blank. Now select the pinion gear, set origin, geometry to origin, so it's in this position. We are going to hit this button, press G to move it, set along the Z axis, and we want to place it like so. It doesn't matter if it is right in the plane, we want to move it just like so. Now we want to rotate this, so we press R for rotation in the Y axis, and we want negative 90 degrees. Enter. Now select the crown gear blank, rotate z-axis minus 45 degrees, so it is positioned in this direction. Okay, now select this one, press G, X, and we want to move it like so, making sure we have a bit of clearance from the base of the rollers, and the rollers are sticking out a little bit. We want to move this upwards, so G set 12.5 millimeters, this is the radius, and we also want a bit of clearance, so G set 2 millimeters. Okay, now this is the top roller, but you can choose any of the rollers. We want this to be at the bottom. Okay, so rotation, x-axis minus 90 degrees, and as you can see, we have the top roller at the bottom, just like so. You can select any of the rollers and calculate the corresponding angle to rotate it, but you should have something like this. We want to select the pinion gear, press N to open this panel, and as you can see, these values we want to be 0, 0, 0. So for this we are going to hit Ctrl A, rotation, and we have everything on 0. We are going to rotate this. Remember, this is 18 degrees. So rotation, z-axis minus 18 degrees. And we want to move it another tooth over. So rotation, z minus 18 degrees. Ctrl A, rotation, and we have everything on 0. Now we want to make the pinion gear a rotating object. For this we are going to move this upwards, move this to 0, select the pinion gear and hit K, rotation. Move this slider to 200, for example. You can choose any number. And we are going to hit rotation, x-axis, and we want this to be rotating like so. So we are going to hit in here minus 360 degrees. Okay, hit K again, rotation. And as you can see, we have a rotating pinion gear. Now select the pinion gear, hit A in here to select both keyframes, T and linear. This makes it so the pinion gear rotates at a constant speed, just like so. Now we want to link the rotation of the pinion gear with the rotation of the gear blank. For this, we are going to move to 0, select the crown gear, and as you can see, this is rotating in the x-axis, but we want this to be rotating in the z-axis. Okay, I'm going to set this at 0. In this panel, hit right click, add driver. In input variable, we want to select the pinion gear. Okay, edit driver. We want to move or choose the X rotation of the pinion gear. Edit driver again, and the expression is going to be bar, the name of our variable, divided our gear ratio, which is 4. Just like so. Okay, now if we hit space, we can see it is moving, and we want this to be to the other side, so we can do it in two ways. We can change the rotation. For instance, over here in the 200 keyframe. We can set this to 360 degrees instead of minus 360 and hit K rotation. Now, as you can see, it is spinning the right way. Now we select the crown gear blank, we go to modifiers, add modifier, geometry node, hit new, and we are going to call this cut gear. In here, scroll, go to geometry nodes, making sure it says cut gear. Okay. First, we are going to hit Shift A, search simulation zone, just like so. Disconnect this one. Now Shift A, mesh boolean, put it in the middle, making sure the geometry goes to the mesh 1 and the mesh output goes to the geometry over here. Okay, set this to difference. We want to enter our geometry of the gear blank and we want to output the result to the output. Okay, we want to select Shift A, object info. In this, select the pinion gear, check relative, and we select or connect the geometry to the mesh 2. Okay, now if we go back to layout, now as you can see, if we hit space, it is cutting the tooth geometry, but our gear blank disappears. This is because we forgot to align the gear blank with the first roller. Okay, for this we are going to select the gear blank, go to the 0 keyframe, delete the driver, and we want to position this just like so. Rotation minus 45, positive 45, just like so. Remember, this is spinning in that direction. So we want this to be to the other side. So rotation set minus 18. Okay. So before we had this roller in the middle of the tooth, we want this roller to be at the edge of the tooth, just like so. Now we can rotate this one tooth over. So rotation set minus 18 degrees, just like so. Okay, and we could do another tooth over if we want. For instance, rotation set minus 18 degrees, Control A, rotation, and we should add the driver again. So add driver, bar over 4, we want to select the pinion gear and the X rotation. Now, as you can see, if we hit space, we should have the right tooth geometry. It is a bit slow. Okay, and once we clear the rollers, this is the tooth geometry we end up with. If you wanted more resolution of this process, you can select the pinion gear and move this keyframe over to the right. So each keyframe the rotation, the angle of the rotation in the pinion gear is smaller, for instance like so. And you should calculate again the geometry. Sometimes it can do weird stuff like this, but this is because we are doing thousands of Boolean operations. So you want to keep that in mind when moving this to the right side. Okay, this is a mess. We are going to move it like 100, for instance, so it is going to move pretty fast. And here we have less resolution. Now, as you can see, if we select the gear blank and hit tab to see the geometry, we still have the original blank geometry. For this, we are going to go to modifiers, in here, apply. So we have now the correct geometry. In edit mode, which you enter by hitting tab, we are going to hit P by loose parts. Okay, so now this is a body, this is another, and this is another. We can select these two, hit X, delete, okay, and we have one of the dudes. Now we are going to hit tab, number 3 to select faces, and we are going to select all of these faces. Okay, hit X, faces, and we should have something like this. Now we can hide the pinion gear, select the gear we just made, go to modifiers, add modifiers, array. We are going to hit Shift A, empty plane axis. So we have a plane axis in the origin. We are going to rotate in the Z direction 18 degrees, just like so. Select the gear blank, uncheck this, and select object offset, making sure you select the empty. In the count, we want 22th. And as you can see, it is a mess because we are still animating the rotation of the gear blank. For this, we are going to delete the driver, and we want to set this to 0. Okay, if we disable this, you can see it is in this position. When we activate the modifier, you can see we have the gear blank. Now this has some problems because these are not joined. What do I mean when I say these are not joined? Well, if we apply this modifier, you can see, or maybe you can see, these two lines are not welded together. So for this, you have two options. You can go to modifiers, add modifier, weld, set this to 0.2 millimeters, and you can apply this modifier. You will see some weird active artifacts like this. So maybe 0.2 is a bit too much, 0.1 is okay. So this is one option. Another option is to go to 3D print, this is an add-on you can install. Go to check all. This is going to check the geometry, and as you can see, non-manifold edges. We have all of the seams that are not connected. So we are going to go to cleanup, make manifold, and in here you can bump this up a bit, just like so. If we check again, we have 0 non-manifold edges, which is exactly what we want. We are going to select the gear we just made, go to File, Export, STL, and we want to save this as final gear, selection only, export. Now in Solidworks we can drag the final gear just like so, but as you can see this is a graphic object, so we are going to right click, convert to mesh body, making sure this is selected. This is going to take a bit of time. You might happen to have this error. Okay, and now you can see this is a mesh object, so this is a solid body. Now these lines are a bit annoying, all of these lines, so you can work around them with this button, just like so. But as you can see, if we want to select this face, this flat face, or this bottom face, we can't, because this is a mesh object. For this, we are going to right click in here, segment imported mesh body, and hit OK. Sometimes you will need to do this, sometimes you may don't have to do this. Okay. Once the segmentation is done, you can see we have flat faces in which we can make sketches. So now you can add all the features you want to the crown gear. For instance, I'm going to make a sketch in this face. With some holes, just to make an example. Features, extrude cut, and as you can see, you can make all the operations you want. Now I'm going to extrude in here a cylinder to show you an error you could have. For instance, this is going to be 25 millimeters and 5 millimeters. When you want to extrude, sometimes it might just work, and sometimes this face might not be flat because we turned a mesh object into a Solidworks object. Okay, so if you, when you want to extrude, you can't, you get an error. One solution is to, in here, extrude in the other direction just 1 millimeter, like so, so it is firmly connected to the gear blank. Now with this you can do all the operations you want. For instance, you can add a 2 millimeter chamfer in here and in here. Okay, you can add all the operations you want. Finally, if you want to 3D print this, go to Save As, STL, and Printable Gear Crown. Okay. Finally, you can move the printable gear crown to your favorite slicer, and as you can see, you have the crown gear we just designed, and you can 3D print this. Of course, if you wanted to 3D print this, you should have supports, but as you can see, we have all the features we designed. For instance, this chamfer. This doesn't have any weird geometries inside it. And we have perfectly trochoidal gears. Now, as a bonus, you can create an assembly, insert the pinion gear. In this plane, you want to make a sketch in the origin of something like this. This is going to be 65 millimeters, and this is going to be 2 millimeters of the clearance of the crown gear plus 3 millimeters of the radius of the rollers plus 12.5 millimeters of the radius of the pinion gear. So this value. We are going to insert now the gear we just made, relationship, this and this should be concentric in the other direction. Now this point and this face should be coincident, just like so, and we want to float the pinion gear, so we can move it. This and this should be concentric, and this from this should be at a distance of 60 millimeters, a bit less, 56 millimeters. That's good enough. Okay. Now this must be longer because we are measuring from here and not from, we are not measuring from here, we are measuring from right here. So this is 5 millimeters plus 10, so this is plus 15. We can reconstruct, and as you can see, the roller is in the correct position, just where we want it. Okay, maybe the clearance was a bit too much, 2 millimeters, I don't remember if we set 2 millimeters or 1.5 millimeters. But we can make a relationship, mechanical, here, and we want to select this face and this face. Okay, and this should have a 1 to 4 relationship. So when we spin this, the wheel moves, but it should move in the other direction. So we are going to edit it, reverse, and now as you can see, you have the gear reduction we wanted. You can do a detect interference detection, calculate, and as you can see, no interference were found because the tooth geometry is correct. With this, you can add mounts for the pinion gear and the crown gear and keep designing as you wish.